IGCSE Computer Science. Syllabus Statement 1.4e, Show understanding of the use of authentication. So in the last video we looked at hashing in encryption. So we looked at how hashing could increase the security, but we didn't really go into that. So this video we're going to go into that, and then we're going to move on to methods of authentication. So again, the reason why I decided to put hashing here is because this is linked to one of the authentication methods, which is digital signatures, and also it's used for verification. So it's used to verify data because a hash can't be reversed to get the original message. So this is why it's kind of authentication. It's sort of follows that path. It's not really like encryption, but encryption does use it if need be. So like an example would be a password is stored on a database, but as a hash. So the user enters their password to log in, and the password is then hashed, sent to the wherever it gets sent, and then is compared with the stored hash. Actually, it would get sent to the server or whatever's the website. And if they match, access is granted. If they don't, access is denied. So why can't hash be reversed? Like why is that? How does that work? Well, let's put it this way. Say the hashing algorithm was x times y. X and y are numbers. So say x equals 5 and y equals 10. So it would be x times y, so 5 times 10, which gives us 50. So the 50 is the hashed value, and it's sent to wherever. Now here's the thing. How would the algorithm know what produced that 50? Like, it could be 5 times 10. So it could be, x could be 5, y could be 10. Or it could be something else, such as 25 and 2, which would also produce 50. So the algorithm wouldn't know what would be produced. So with that said, you can kind of see how hashing can't be reversed, as it's really hard to get the it's basically, it's easier to go forward than backwards. And there's also one more thing I was going to say, but I can't really remember what it was. It was something like, oh, right, yeah, I was going to say, like, that algorithm, the x times y algorithm, is pretty basic. Now, keep in mind that hashing algorithms are a lot more complex than that, and x and y wouldn't be really small numbers, like 5 and 10. It would be pretty big numbers, right? So it's all of that, taking all of that into account, and the value would be much larger, the hash value would be much larger, which makes it even harder to get the original values. So you can kind of see why hashing is a forwards process and not a backwards process. So that's why it's used for verification and not encryption. So let's look at some hashing algorithms. Like, take the MD4 hashing algorithm, and then it'll produce this. So if we input hello, it would produce this. If we input hello world, it would produce this. As you can see, there's a huge difference in the values. And all we did was add a space and world. If you tried to find an MD4 hashing algorithm online, and you input hello, but with a capital H, you'd notice sort of a similar difference. Like, the difference would be pretty big. There's also the MD5 hashing algorithm, but this is just to show you, like, the point is hashing is a really complex process. But if you notice, all the hashes have 32 characters, and this makes them 128 bits long. Strings that are 128 bits long give 3 times 10 to the power of 38 possible combinations, making them very secure. Some newer systems use strings that are 256 bits long, giving 1 times 10 to the power of 77 possible combinations. So, what do these have to do with anything? Now, here's the thing. If you think back for what we learned to what we learned in the last video about hashing being applied to encryption, you notice that we did talk about how the encryption keys are often generated by using a hashing algorithm. So what this basically means is, with larger bits, there are more possible combinations. So the larger the key size, the more secure the encryption will be, the more possible combinations. So let's look at digital signatures. So this system is based on public key encryption. That's asymmetric encryption. It's used to validate the authenticity of a message or electronic document. And it's kind of like reverse asymmetric encryption, but also makes use of hashing. Now, this kind of, you might be thinking, wait, hang on, what? Reverse asymmetric encryption? Well, you'll see. So, user A writes a message. The message is put through a hashing algorithm, and also keep in mind that this is authentication. So, although there is encryption involved in this, that's not really the main point. So, private key encrypts the hash. So this is the digital signature. It's then sent along with the message, so the encrypted hash and the original message, which hasn't been encrypted or hashed, they're both sent to user B. User B then decrypts the hash using a public key, and then uses this decrypted hash and basically compares it with the message by hashing the message as well. And it basically checks if data has been altered. Now, hang on, what's the point of doing this? Well, and how does it reverse asymmetric encryption? Well, let's address that first. It's reverse asymmetric encryption because we see that a private key encrypts the hash here, and a public key is used to decrypt it. When we learned about asymmetric encryption in the last video, a public key encrypted the hash, and a private key, or well, not the hash, but like the message, but you get the other point. A public key was used to encrypt, and a private key was used to decrypt. Here it's the other way around. Private is used to encrypt, and public is used to decrypt. So what's the point of doing that? Wouldn't that mean that like anyone could decrypt the hash? Wouldn't that, well, yes. But the whole point of this is verification. So this basically checks if the person sending the message is legit. The person is like actually, you know, they are authentic. That's pretty much the point. If you're confused by any of this, I suggest you go online, because I looked at some good sources of information, and so if I'm not explaining clearly enough, just go online, because this is quite a complicated topic to understand. But once you understand, you sort of get the idea. Anyway, let's look at something easier. So let's look at passwords. So everyone knows what a password is. So passwords, along with usernames, are used to log in or log on to many systems. Just like you could take Facebook, for example. Yeah. So when a user logs into a system, both their username and password are entered and are checked against the stored username and password on the database to make sure the person logging in is who they claim to be. If they both match, access is granted. If they don't, access is of course denied. And as said, passwords stored on the database can also be hashed to increase security. So the password sent when the user logs on is hashed and then checked against the stored password. So this is, this increases security because A, the password sent is hashed, so if a hacker intercepts it, they won't be able to make any sense of it. And B, because the password in the database is also hashed, then there's no way, if someone saw the passwords, there's no way anyone could, dehash it or anything. Also, another point which is really good to make is it's important that hashes don't collide. What that basically means is hashes, like each value which is hashed, has to be unique. So take the word Shrek. So if Shrek is hashed, it may produce a certain hexadecimal value. And then take the word, let's see, what other movies do I have? Okay, take the word Battlefront. So Battlefront will have to have a different hash value than Shrek. If they collide, so basically if Shrek is hashed and Battlefront is hashed, and they have the same hash value, because of course there's no way that you could dehash something, then that kind of poses a problem, and you can kind of see why. So it's important that all of these are unique. I don't know if you get what I'm saying, but no need to worry about it though, because it's not really important. As long as you know that hashing is a forwards process, then yeah. So biometrics. So this is the last authentication method we have to look at. And this type of authentication method uses physical qualities of humans. So this could include fingerprint scanners, retina scanners, facial recognition, and voice recognition. Now, here's the thing. We're only going to look at fingerprint scanners and retina scanners in this video because we looked at facial recognition and voice recognition in input devices. And that basically describes how they are used. So if you want to go there and check them out, you can go ahead and do that. So we'll just move on to fingerprint scanners and retina scanners. So the user is asked to place or swipe their finger on a sensor. The image of their fingerprint is then compared with a stored image of their fingerprint. And this is done by software looking at patterns of ridges and valleys. If they match, the user is granted access. And if they don't, of course, they're not granted access. In case you're wondering what ridges and valleys are, these are ridges, those little things here, and valleys are those weird thingies here. Retina scanners are a little bit different, well, a lot different. So the user is asked to sit still for 10 to 15 seconds while the scan takes place. The scanner uses infrared to scan the unique pattern of blood vessels at the back of the user's eye. Weird. The image is compared with a stored image, and if they match, the user is granted access. But this method is more secure than fingerprint scanners, because no one has found a way to duplicate blood vessel patterns. Here's what that means. So you take this eye here, for example, look at these blood vessel patterns. Now this is pretty complicated to copy, because you have to look at like all these little things and all that, and it's in the back of the eye. I mean, come on. It's really hard. So you can think like, we could see our fingerprint like right in front of us. But the blood vessels at the back of our eye, we can't really see those, because, we're seeing from this point and they're back here. So there's no way we can actually see them. So it's pretty hard. So that's the end of authentication. So that's the end of all the hard stuff. That all the confusing stuff that you have to cover. Because the next video is, I believe, going to be about, if I can remember off the top of my head, if this is 1.4e, then F should be, I can't remember. Well, anyway, you'll find out. I think it's something to do with phishing and farming, as well as denial of service attacks, but I'm not entirely sure. I think it should be. But yeah, thanks for watching. And if you need any further assistance, Google is right in front of you. Well, maybe not right in front of you, but Google is available.